types of software analysis information that can be modeled by object diagrams. And illustrate your explanation with diagrams. Okay. So software analysis has three parts basically: analyze objects, analyze interaction, produce classes. We are concentrating on this part. It has derive features, derive links, and define the structure. Now I will take you here. First part, study feature. So this is an object, unknown object of emergency reports class. These are the properties of the object, and this is the operation in the object. So this is the study feature part.
Okay, the second part is the study information links, which shows the links between the various types of objects. Basically, this diagram shows that the link between field officer and emergency report is that field officer writes the emergency report. The emergency report is triggered by the incident, and the field officer reports the incident. So this shows the link between the three objects. The third part is we study the structure of a particular object, the structure links. So this shows that there are three types of incidents. Minor is an incident, emergency is an incident, and disaster is a type of incident. And again, cat in a tree is a minor incident, fire is an emergency incident, and earthquake is a disaster incident. This shows the composition of this, how the structure within this class is.
Okay, how do you know that this particular linkage actually exists? How do you know it exists? Since the software doesn't work yet, you don't have software. So how do you know that linkage exists? Maybe a prototype, but chances are you wouldn't do the prototype till after you've done this diagram. So where does this information come from?
Basic aggregation.
Okay, this would point to aggregation, yes. But how do you know it? When you're doing this diagram, how do you come up with this link?
From the class diagram.
There's no class diagram.
From the requirements, the specification requirement?
Yes, it comes from the requirements themselves, and this chances are will be a non-functional requirement. Chances are. I mean, it's not always, but so this information you derive it. It's not there specifically. It doesn't poke out of the requirements and says, yeah, use it as A here. You get it. That's what derive means. So that's the whole point, is you're making this up from the limited amount of information you've got. And then you, as a designer, can say this type of sentence means is A. Okay, so that's very important. The word is derive. And there was a group before you that had to do this exercise. They had to actually derive this whole stuff for a parts management information system. So take a look at that in the wiki. So they did the derivation. There was no thing, they had to derive it from scratch. Okay? Great. Okay, thanks. Let's look at this one here.